All right, the last lesson here is just pulling together the few bits and bobs that we've already mentioned, we've already talked about in the semester, or sorry, in first semester, and then a little bit this semester, and just pulling it all together and making sure that we get one last mention of them. So first of all, average value. This is a formula that you'll have to learn. So if you integrate a function from a to b and then divide by the width of that function, you get the average value of the function. And the way you can think about this is basically you're adding up all the tiny changes. All the way you can think about this is imagine for a second that you're just doing a Riemann sum where each one is one long, if that makes sense. So if we have our function like this, so I have 1, 1, 1, 1, 1, 1, 1, 1. So the average of this function would approximately be, if each of these is 1 wide, it would basically just be average these numbers like usual. Well, what's the steps that you do? That would be add them, and divide by the number, right? Add up all the y values, divide by the number. Well, the heights in this case is also equivalent to the area because they have 1 wide. And this number is also equivalent to the width. So functionally what we're doing here, it's the same idea, just then you make these smaller and smaller. You end up getting an infinite number of them, and because of the ways that infinities work, this ends up still holding true. It's not something I want to spend a whole lot of time on because you can kind of imagine it from this Riemann sum example, play around with it. If it is something that's confusing to you or you want to talk about more, let me know in class and we'll go over it. But I think for a lot of people, this should be sufficient because either you just want to memorize it or you can kind of see how that works to get you the average value. Then lastly, for kinematics, this is just a real brief reminder and summary about the relationships between all the terms. We talked about it pretty extensively in the last unit, but it's basically just that the velocity is equal to the integral, or the change in velocity is equal to the integral of acceleration times time, and the change in position is equal to the integral of velocity with respect to time. And so the kinematics, it's just going back and forth between velocities, accelerations, positions, etc., and just whether you're integrating or deriving and finding the relationships there. It's something that just as you practice it, it'll get more and more comfortable. And so that's the last thing we're going to look at here with applications of integration.